Each year, the Sherman Contemporary Art Foundation provides a grant based on submissions from 10 emerging Australian architects. And at this year's event, we get some insight from the winning designer and his team.
The whole idea is that as you walk around, it's you see the outside shape and all the Corian, and then you come down and around, and it's a surprise as you come onto the inside. So it's really about creating that intense experience of moving from the outside to the inside and walking through it. Every single piece is unique. There's 152 pieces of Corian, and then the same 152 pieces of stainless Rymex on the inside. And all of the bracketry, which holds it all together, is 452 brackets, each of which has between 2 and 5 legs. Working with Alex Edwards from Arup, it became a real design feature to have the Corian support itself.
There were two competing ideas, I guess, early on in the process, and one of those was to actually make the Corian the structural element, and one of them was to have it on some form of frame or skin. We use a structural analysis software called Strand 7, and we use that on quite a lot of things, from big sports stadium roofs down to connections and joints and bridges. But I've also got an analysis model for this structure that I put together where I model the stiffness and the strength of the material, plus also the connections and how the panels connect one to another. And I can put the wind loads on that and come up with stresses that I can compare against the material strength. Corian's available in 2 different thicknesses. There's a 12mm thickness and a 19mm thickness. We were hoping to be able to use the 12, but it ended up at the thicker 19. The reason for that was really to control the buckling of the structure.
Materials heated up to 160 odd degrees for an hour to 2 hours, depending on the thickness. And we pull it out, and goes into a male-female jig, and it's cured overnight. We were sceptical, to be brutally honest, Okay. But as soon as the engineers' reports came in, they said it's good to go.
We'd used Corian once before on a project, and the thing that we liked about it is it's very easy to work with. Like, you can route it and cut it and sand it. So it's very forgiving, it's flexible, and it's very strong. It's 6 times less strong than steel, which is still very, very strong. The Corian's completely self-supporting, so it stands up on its own. We built a scaffold upside down, and we propped the whole thing and built it as we went, so one side to the other, and built the entire structure in 4 days, and then came in and did the interior in 4 days after that. Basically, every panel is rebated in order to allow all the water to run off, so we don't have any water penetrating the skin.
The shape that it has gives it its stiffness. So the structure is working as a shell structure. So a little bit like an eggshell. It's very, very, very slender, but actually quite strong for what it is.
Terry Tisdale from Ox Engineering, together with Robert and Gabrielle from Armour, were developing the robotic technology at the same time the structure was being designed. It's a self-sustaining structure. Every piece is adding to the engineering miracle that you see before your eyes.